that there is going to be a lot of fireworks when artificial intelligence meets natural intelligence. Natural intelligence may mean the intelligence we humans have. This was exactly depicted in the brochure on this seminar. I am thankful to Aravind, who is also one of my students and an artist, to have shared his image that he used for the preparation of the brochure. During this talk, we shall explore how far his expectations on the Big Bang that is going to be is true. So sit back, relax, and enjoy the show. Yes, this will be a show rather than a scientific talk. I would try to avoid any use of scientific terms or scientific jargons in my talks because I know that this is a heterogeneous audience and it's not the place to show my scientific knowledge to anybody. So sit back and relax and see what is happening around us. So before we answer the question, what will happen? Let us look where it is going to happen, where it might happen. We all know that we are all wired now. Each of us are sitting in a different place and is everywhere at the same time. 50 years ago, if somebody would say like this, you would definitely call him mad. This massive wiring that connects us together is what we call the internet. We do our banking through internet, our chats through internet. Even our jobs, thanks to the pandemic, are done through the internet. And imagine a situation in which there was no internet and we have this pandemic. There is no way we could communicate. Our TV channels are all on the digital media now. It used to be analog. Let's use the jargon. Okay, it's in the digital media now. It's on the internet now. Our phones run on digital media. Our classes are conducted on digital media. All harness the power of the internet. So naturally, it is here in this global platform that we are going to encounter artificial intelligence. The internet carries huge volumes of data. The daily volume of data created on the internet in 2020 was about 2.5 quintillion bytes. 1 quintillion is 1 followed by 18 zeros. How big is this? Our galaxy, the Milky Way, we know that the Milky Way is the galaxy in which our sun is a star, consists of about 10 raised to 9 stars, or maybe 10 raised to 10 stars. But that means 1 followed by 9 zeros or 1 followed by 10 zeros. But what I am talking is about 10 raised to 18, which is 18 zeros followed by 1. That means there is space for 10 raised to 9 galaxies. The number of stars in 10 raised to 9 galaxies to be the size of the data that we created in one day in 2020. In other words, if I replace every star in our galaxy with a galaxy similar to the Milky Way itself, what number it comes to, that is the amount of data that was created in one day in 2020 on the internet. So it's a huge data, anything more than any of us can imagine. So huge. Naturally, as a result, it is impossible for human facility or to human faculty to organize and handle all this data in the natural, in the standard, in the formal way. But nevertheless, Google answers correctly most of the questions we ask in a fraction of a second. If you ask anything, you ask about me, you ask about Aries, you ask about your college, Google immediately gives you the answer. How is it possible for a simple service like Google to do this? How is it possible? This is made possible by the highly powerful artificial intelligence models that work behind the scenes. So you see what is happening. But how do computers understand our language? With the help of AI only. There is a branch of computer science called natural language processing, or NLP, that is based on AI research, that is based on AI, artificial intelligence models. It enables machines to understand languages, slangs, and even translate one language to another without the help of a human. Languages are very complex. Each of us have our own slangs in which we talk. Each of us have our own styles in which we express things. And the computer has to understand. Machines can understand the style and quickly recognize how I speak, how a different person speaks, and even can understand my voice from a crowd. So powerful is NLP, and the capability they have in understanding human language. At Aries 4D, we have a research student, june17. She is a full-time researcher exploring for the potential of natural language processing using the principles of physics. She currently works on an exciting problem called multi-instance, multi-label learning, or MIML. Though it requires some understanding of the background of my talk to understand what this is all about, I'll just try to explain it in simple terms. Until recently, we had to teach the computer like we teach a nursery school kid. What we do, we should show him a pencil and say this is a pencil. We should show him a book and say this is a book. And we need to keep on doing it until the student is able to see a pencil and say this is a pencil. And when he sees a book, should be able to say this is a book. So what happens if I show him a pen which he has never seen? Definitely he would say, oh, that is a pencil, which is wrong. And machines also do the same thing. When you teach them on different problems, you need to train them on similar data so that the machine will be able to reproduce it in the same way. This is not a problem when your data size is very small. But assume the case of the internet, which has so huge volumes of data that is being created every day. It is impossible to train a machine with all the possible examples. So this is where the real problem comes. We cannot train the machine on every piece of information that it should learn. So the training data that we create will be insufficient for doing the kind of training we want. So what is the way out? So this is the question that she is trying to answer. Unfortunately, it is impossible for us to train a kid on every future encounters he may have in life, because the future itself is changing, the environment itself is changing. Multi-instant, multi-level learning that Jinsu developed does things at a higher level. What does it do? Instead of showing the kid each example, like a pencil or a book, point the kid to a tree and say, there is a crow on that tree. The kid may not be able to identify the crow at the first step. But if we keep on doing this, whenever there is a crow somewhere, the kid will eventually learn to identify the crow and what is not a crow. Then later, when he encounters a crow in a totally different situation, he would point to the crow and say, Mama, here is a crow. This is exactly what multi-instance learning does. You do not catch the cow and show it to the kid. Instead, you bring the kid to a scenario or to a situation where there is a cow and tell there is a cow. And you do not show which one is a cow. You say there is a cow in this picture. You show another picture which has a cow and a dog or something. You say there is a cow in that picture. And you leave it as the responsibility of the kid to identify which is a cow and which is a something else, a dog or a cat or something. Now, suppose I also have different objects like this in my data set, then I can tell the kid that there is a cow in that picture, there is a dog in that picture, there is a cat in that picture. Then show another picture and say, oh, there is a dog in this picture, there is a cat in this picture, there is a crow in this picture, and like that. Now I am giving lot of examples and lot of labels to the kid and asking the kid to find out which is a cow, which is a crow, which is a dog, like that. How will he do it? He will go through all the pictures, look at the common factors, and will say, oh, these all pictures had cow, so this should be the cow. These all pictures had crow, so this is the common picture that I am seeing, so this should be a crow. And this is exactly what Jinsu is doing with multi-instant, multi-level data training. So it has a lot of applications, right? In not only in language processing, in many other areas, it has a lot of applications. So this is the kind of work NLP is doing these days, and it will definitely help us in many areas. I'll just give you an example. Cancer case. See, we have cells in our body, some of which misbehave and become cancer cells. And what the pathologist does when he sees the biopsy is, he looks at the cells through his microscope and find out the morphological difference. Morphological means the structural difference. As you can see in this image, there is shape difference in the nucleus, in cytoplasm, in the cell structure, everything. There is difference in shape. And the pathologist uses this method to identify that you have cancer. But there is a problem again. What is it? Remember the example of the crow in the tree. It is very difficult for the pathologist to detect cancerous cells in its early stages. Once the cancer has grown to sufficiently large size that there are a lot of cells which are infected, then it is easier to identify, oh, he has cancer. The early detection is very important. And if we can train the machine to understand that there is a crow and to identify where the crow is sitting on the tree, then definitely the same method we can use to allow the pathologist to detect even single cells which have got cancer. And this will allow early treatment and also will save lives. At Ares 4D, we have the Ares 4D, the main aim is to focus on artificial intelligence data. We work on machine learning tools, development of machine learning tools, and also for using it on real life problems and real life situations. So we are also very focused on the biology side of artificial intelligence application. And in fact, we have I have a colleague named Geeta Kaur, who is handling the bioscience portion of our artificial intelligence applications. We collaborate with hospitals, national centers, and various research institutions across the country for implementing biological applications in machine learning. And one of the first projects that we started on this was with the National Knowledge Network, NKN, and that is how this collaboration came into existence. And it was for the detection of miscarriages in women across the country. So there are various areas where there is applications in which this machine learning finds a lot of applications. And Geeta Kaur herself is a very good expert in odontology studies, and also fish and wildlife biodiversity. So I just want to casually mention to say that we have a heterogeneous environment, and we focus on various topics which have a lot of significance in machine learning. Now, recently, it happened that Aries has been on news uh, for developing a tool that could automatically pick protein particles from cryo-EM images. The paper appeared in Nature's Communication Biology journal, and there were 8 authors in this paper, 3 of them from the National Center for Cell Sciences in CCS in Pune, one from the Inter-University Center for Astronomy and Astrophysics in Pune, and the 4 others were from Aries. And the complete AI-related technology for this purpose was developed by Aries. I shall use this as an example to demonstrate how AI can supplement our advancement in medical and scientific activities. So I promise I won't go into the, but will just give you an idea of what it is. So every protein in our body has a unique structure. And we are, in fact, life won't exist without proteins. Our entire body is built up of various proteins. It is the structure that gives them the properties to do the kind of job they are supposed to do. For example, the antibody protein, as you can see in this image, is one that gives the protection about foreign invaders like COVID-19 pandemic. It has something like a T structure, T shape, as you can see, and some fine structures that help it to lock with the foreign protein and flag them to another cell, which comes and injects poison into it and kills. So these things are happening in our body without our own realization. When you take a vaccination, I had one vaccination today for COVID. Your body creates antibodies for the structure of the infected dead protein and train itself to be prepared when the real virus comes. It is the structure that decides the function state, the protein. There are 2 problems here. Number 1, when we try to understand the structure of the protein, because we need to know the structure of the protein to create medicines, to create chemicals that would bind with them and would help the body to identify them and to destroy them. In fact, all the job is done by our own immune system, but all these things just catalyze the process. What that we face when we go to identify these? Number 1, look at their sizes. They are in nanometer scales, 10 nanometers. And that is very small. I told you about the galaxy. We have some 10 raised to 9 stars in our Milky Way. Suppose I pick up each star and reduce it to the size of the protein, the amino acids in the protein, and put them in the form of a line. I finish putting the last star in my line, each star with the same size of the protein, then I would have reached a length of 1 meter. So that's small. So tiny. So first of all, we cannot see them under ordinary microscope. So that is problem number 1, which means that we cannot use light to see them. Because if you know the physics, you know that the wavelength determines what the resolution you can get. And these are jargons, I won't go into that, but that is possible. So what we need an electron microscope. Because electrons have shorter wavelength, they can have higher resolution, you can see. But there is second problem. These are all organic cells. What we are talking about is organic cells. As soon as you bring them under the beams of the electron microscope, they will be reduced to ashes. So this was a problem for long. until cryo-EM method was discovered. What is cryo-EM method? What they do is that you take the protein, you make a thin film of it, and you immerse it into deep freezing conditions where this turns into glass. Once it becomes glass, it becomes solid. Even if the protein inside it gets burned, the structure will remain. And using a technique called transmission electron microscope, CHEM, you can see the structure of the protein. But in an image. Suppose I keep my hand before a light, I'll get a shadow. But the shadow will not have the three-dimensional information I have. So here we have the third problem, which is not a big problem because we have already solved it. It was a big problem, but it was solved and it got a Nobel Prize. Definitely it should. So we now know that doing a technique called Fourier transform, those who are in the mathematics branch knows Fourier transform. What Fourier transform is. Also the physics students also must be knowing what Fourier transform is. Using some techniques in Fourier transform, we can convert these two-dimensional images. If we have different orientations of the two-dimensional image, we can convert it to get to three-dimensional information, which is what you get when I rotate my hand like this. And we are interested in this three-dimensional structure of the protein, which is not as big as my hand, which is very, very small, as you have already seen. So this is the challenge. And when you do it with the electron microscope, what you get is what is shown in this image. On the right hand side bottom, you can see a very small box. It has all the proteins that were made into glass on the thin film that we created using the cryo-EM. Now, to explain or to understand it better, let us try to zoom it in and look at it. Now you can see those teeth-like structures in some patterns which are circled there. You can see the antibodies that were, proteins that were there. So there are a lot of them in it, but we will be able to see only those which come in focus with the electron microscope. So these focus images, you have to manually pick and identify as protein for the 3D reconstruction process. And this is exactly where we introduce the AI technique. What we did is, this is not an easy procedure. Even for the expert, it would take at least a day or a week's time to manually pick up all the thousands of protein orientations that are. And there is a lot of noise also in it, which he has to avoid. So he needs to train himself for a long time for understanding which is a protein and which is some contaminant in the soil. Now, when we introduce this machine learning tool, what it could do is, instead of taking just 2 weeks or a few days time, it could do the whole of the correct protein in a fraction of a second. And that's why it got published in Nature. So this is what it does. You have the image which is on top, which looks like a blank thing. You need to do some image enhancement, and then once you do it, the AI tool will label them as protein, as you see with the red color marks. These are different proteins that are labeled, different types of proteins that are labeled. So the tool that we use is something that was already known, which is called semantic segmentation. In semantic segmentation, what you do is, it is being used in automated car driving, for example, where you want to identify different obstacles that come on the road. We need to find out when a pedestrian crosses, we need to find out where another car is there, what the signal is, all these things you need to know. And this was done with semantic segmentation. So we used this tool and modified it so that it can be used in cryo-EM. It was labeled Casper, and it can label protein and also contaminants in the image. To understand what this means, look at this image where you can see pedestrians driving the cycle. You can see that the predictor colors are unique here for the cycle and the pedestrian, which means that once we have the training done on the AI, the same thing can be used to predict in future what the kind of protein it is, and which is the protein and which is the background and which is uh, the which could be a contaminant. All these things you can get. In Casper, it looks like this. What you see here is the protein which are shown as red. Ice and contaminants are shown as yellow, and the background is shown as blue. So you see that we are able to now do a 3-week process, reduce it to a few seconds. And what is the advantage? One advantage we have already seen. Casper could reduce the protein particle picking time from weeks to a fraction of a second. The faster we know the structure, the faster the drugs and the vaccines can be. So it is a great advantage of using AI. But more importantly, the accuracy of the machines are much superior to the human eye. And as a result, the protein reconstructions, 3D reconstructions we could make are the best available for these proteins. You can even reconstruct the twists and the bones. Well, story never ends. On November 30th, 2020, the computational power of DeepMind, a huge computing system that attempts to cross the horizons of human scientific advances in AI, shattered the world with its breakthrough in decoding one of the greatest puzzles biosciences ever had, which is called the protein folding problem. I told you that proteins have unique structures, and it is this structure that makes it a protein. If it loses this structure, it can become cancerous and it will be considered as useless material by the body and will be thrown from the body. And all these proteins are made up of some 20 different amino acids, their combination. You can think of it as a long chain, but remaining as a chain, it is useless. Only when they fold and they get a particular shape, they become useful for life-supporting phenomena in our. So the entire power depends upon the three-dimensional structure, which is the reason why we were investing so much of AI on detecting the three-dimensional structure. So the protein that I show here is the TRPV1 protein, which is a type of protein that is mostly in our nerve system, found in our nerve system, and they sense the pain feeling when I pinch my hand or I hit my hand somewhere. The pain feeling that is carried by this protein, so it stimulates that effect. What is important is that every TRPV1 protein do have this shape, as you see. If it loses shape, as I said, it becomes useless, waste material, and will be degraded by the immune system to prevent it becoming cancerous. So you can imagine the protein to be a long chain of beads, each bead is an amino acid. Ever since the significance of the 3D structure of this protein molecule was known about 50 years ago, scientists have been trying out, working out all knowledge of chemistry, physics, mechanics to understand how this structure was obtained. because there were thousands of different ways in which this could fold. But we have seen in nature that they fold only in a particular fashion, and unless they fold in that particular fashion, the remaining system will throw them out, saying that you are not fit for this, and it will be ejected off from our body into some of the excretory glands. The known chemistry allows thousands of folds, and we know that there is only one way in which it should fold for it to be accepted by the body. There was no understanding how this was happening, and people even imagined it to be the way life. It could be considered as a magic of life or a miracle of life. It is this puzzle that DeepMind AI model using AlphaFold cleared off. So what it did is that it cannot tell you, because all these machine learning tools are like black box. It cannot tell you exactly how it is done. Science usually follow how. It will ask how. It never asks why. So if this tool AlphaFold does not even answer how, but it will tell you, give me the chain, I'll tell you what way it will fold, because there is a science which is much more complex than your brain can normally comprehend. And to give you an example of how this is done, this is what you get using the AlphaFold. You see two structures here, and you can see two colors here, the blue and the green. And as it is written there, the experimental results, where you have experimentally very meticulously found out the structure, is what is shown as green color here. And what is predicted by the AI tool is shown as blue. And you can see that they match very well, except perhaps in some very rare cases like these small regions in the image. So AI has made it accurate up to that point. Why it is important is there are about 200 million proteins, of which we do not have knowledge of the 3D structure. We know we have been able to, so far in the past 50 years, we have been able to decode the structure of hardly 100,000 proteins. And where is 200 million and where is 100,000? So if AI can tell us at least this much roughly what the structure will be, it will be a breakthrough. It will be a breakthrough in medical science. It will be a breakthrough in the drug pharmaceutical industry. And that is why it becomes important. Now, this graph shows the progress that has been made in this area over the past several years. So you can see that we have reached somewhere close to 90%. We have 10% left, which is where further development. But we are very close to the 100% requirement that we imagine to have. Well, that's about the very small structures. Now let us go out to the universe. From the nanostructures, let us move to megastructures, like the galaxy. What you see is a small part of the galaxy called M33, also known as the Triangulum Galaxy. It is a spiral galaxy about 2.73 million light years from us, which means if light starts from there, it will take 2.73 million years for it to reach us. So whatever we see there happened 2.73 million years before, much before we were all on this planet. Now look at this image carefully. Can you see some twinkling stars there? They are not twinkling. This image was created by combining two images, showing one after another, two images that were taken at a difference of about 2 years. The twinkling happens in a millisecond time because of the atmosphere of the Earth. But this is not like that. These stars are actually going brighter, getting dimmer, going brighter, getting dimmer. Like that. That means stars are actually changing their brightness with time. In fact, almost all stars, including our sun, do undergo this kind of cyclic change. But it varies from star to star. The yellowish things that you see coming up and going in this particular image are called Cepheid variables. Cepheid variables change their brightness with a constant period that individually vary from 2 days to 40 days. And it was just regarded as a natural phenomena until this famous lady called Herita Strain-Leavitt made a remarkable discovery that the absolute brightness of the star is proportional to its speed. Proportional. That they are both called. And it was based on this finding made by this beautiful lady that Edwin Hubble was able to predict that the universe is expanding. So this was done by her with a handful of Cepheid galaxies that were known at that time. But right now, we have a lot of surveys that are handled in space and space stations. We have space satellites even, like the Hubble Space Telescope, Chandra, then Newton Telescope, many different telescopes that looks at the variability of the objects in the sky. And that means we have a lot of data. We have a lot of data like what you see in this image. Since we have nowhere to go to them and make analysis studies there as we generally do in the laboratory, we have to wait for the light to come from there and reach us so that we can understand what is happening. There is a whole branch of astronomy dedicated to this variable universe. Two researchers at Ares Body, Lynn Abraham and Sindhu Ji, are using AI-based machine learning tools for studying, understanding the behavior of these variables. Since this is again a very vast topic which includes a lot of jargon, I do not plan to go into the details. I just want to tell you that there is a lot of AI that is required for these studies, and new tools are being developed for them. So we are saying that we are already having meetings with artificial intelligence. Our natural intelligence is on a day-to-day basis is interacting with all these scenarios. Medical science and computer industry are not the only areas with AI has an impact. Remote sensing is just another example. We are all familiar with Google Maps. Every time when we want to go somewhere, we just key in the location and Google will take us there. We are sure about it. How is it done? Using satellite images. Converting satellite images directly into maps can be done by AI. And it's already being done. There is a tool called GAN, which is able to do. Remote sensing satellites continuously monitor Earth's surface, and AI models generate alerts on possible dangerous movements of army troops or explosions happening or smokes from volcanoes coming, forest fires or floods that can affect civilians. They also have eyes that see beneath the surface of the Earth so that they can see water tables, oil deposits, schools of fish going around. That may benefit humans. And in fact, one of I mentioned about Aravind earlier, one of your friends, Aravind. is doing a project with us on similar applications of AI in remote sensing, especially to predict hurricanes and tsunamis. Okay, many of you might have seen helicopters flying over rubber plantation to spray insecticides or pesticides. Pesticides are very harmful to human life. But there are some AI-based drones which have the capability to go to each plant, identify the infected region, and spray pesticides only to the spot where it is. This is called precision farming. And in medical science, there is also precision medicine, which I won't go into now, but it is similar. Where the drone goes to the plant, just like a bee goes to the flower, senses what is there, and does what is there. This will go to each plant, observe what is there, find out where the medicine is to be applied, and applies just that. One of our researchers, the youngest in our group, Robin Jacob, on remote sensing and its application using artificial. His goal is precisely to identify the objects seen through satellites for the welfare of the people, welfare of mankind, and life in general. That includes the entire biodiversity. See, we are not isolated. We cannot live if the bees are gone. That's the famous thing. We cannot live if the biodiversity is disturbed. We think that we can cut the trees and live, but we are already facing the consequences. We are getting too much of rain now because the only reason is climate change. And what is the reason? Deforestation. So this is very important for us to realize and be meticulous in deciding what. Well, we have been talking a lot of science now. Let's go to marketing. There is a common saying that knowledge that is not marketable, that is not value, that has no value in the market, is not worth pursuing. Okay, that's a common statement. I do not personally agree to it at all. I don't believe in that statement. But what I would like to demonstrate is that even if you follow such a definition, AI plays a major role in the market. Online advertising is familiar to us. The typical posters that we use to see on the roadside are now replaced by interactive advertisements that show up on your mobile phones. There is no point in sending a product that is for an elder generation, a person like me, to one of you, because you won't be interested in that. So behind every advertisement that you get, there is an AI machine that checks your age, your sex, and even your personal interests. You give, and that way it is able to give personalized advertisements. There are machines that monitor all your WhatsApp conversations. Even if it is not able to read the WhatsApp conversation, it knows to which community it goes and what their interests are, so that they will be able to predict what your interests are. Your emails are all scanned through. And if you send an email asking somebody for a product, immediately you get an email saying that from somebody else, saying that this product is available with us, you can buy from. So that is what we mean by AI-powered chatbots. There are machines which are dedicated to converse with you, tell you what you are interested in, and make a sale. It is just like what a human salesperson would do. He would come, try to convince you with a hello message, and try to pursue you to buy something. It will introduce you to special offers and free transportation or whatever that would be. It is all done in the background. And the sales department of the company comes to know only when a sale is made. Amazon, Flipkart, and all similar online marketing platforms use AI to cater thousands of customers each day. Remember that these machines are intelligent. The key feature of intelligence is the ability to learn. So with every conversation with you, the AI engine knows you better. You are interested. Not only that, since it interacts with thousands like you every day, it has a better understanding about the trends in the market, what the general public wants. At the end of the day, the machine tells the manager what products and what stocks they should procure to increase the sales and the revenue. This is predictive analysis. On slow-moving items, it would suggest discounts. And on items on demand, it would suggest to increase the stock and the production. So that natural intelligence, the human brain, that harness the artificial intelligence, makes more revenue and reputation in the market. And definitely, the prices of that particular company's share will go up. Though this might appear to be completely artistic and intuitive, web designing is also done with the aid of artificial intelligence. Have you ever looked at the websites of major market leaders like Amazon or Flipkart? Each day, they have a different page of offers and attractions. None of them are randomly placed. The AI engine that works in the background has done its homework well before placing each item for display. As said, it brings in offers for slow-moving items, running out of stock or rush tax for trending items, multiple items and prices, which will have a psychological psychological influence on you to procure any one of them. So that's a topic in psychology, and I do not want to go into that right now. We'll have another talk on that. Okay, the content generation, which is the other area, has to be such that it would attract visitors and make him stick back, searching for the items that you are presenting, and remain there. Definitely that requires intelligence. And it's a pain for a designer to do all of this on an own. Which is the reason why we need to depend on artificial intelligence for doing the marketing. If you are in the market, most of the time you might be selling a product that someone else has. You do not know the durability of the product. You're just introducing it to something. But your success as a businessman is solely based on how reliable you are. Customers are your highest priority, and your profit is secondary. So displaying a set of products won't be sufficient for your success. This is where content curation becomes. Content curation is to add value to the services that you provide, insights and advantages or disadvantages of products that you are putting on. You might have noticed that all service providers these days ask for feedback. In well-established business centers like the ones we mentioned, this feedback is not handled by humans. They are all handled by natural language processing AI machines in the background and are produced and are used for giving the outcomes. And I do not want to go into all the details. Email marketing is another area where you get an email whenever you make comments on its use and application. Then you have voice-based systems which will allow you to talk to a machine and get answers for your questions. Amazon and Google have their Google Home, and Alexa all does the same thing. And e-commerce, of course, is a big area where AI is being. The story does not end there either. One of the greatest innovations in AI technology is the humanoid robotics. And this made a lot of impact when when the robot Sophia was introduced by a Hong Kong-based company, Hudson Robotics, in February 2000. This robot behaved intelligently, participating in interviews and stage shows. In October 2016, she was awarded the Saudi Arabian citizenship, and that is for the first time any robot could get. Sophia is a piece of artwork with the power of AI. She pretends as if she thinks and answers questions very intelligently like a human being. Unlike many robots, she can make facial expressions indicating anger, happiness, or anguish, giving her a realistic appearance. This has brought many lovers, and it is said that perhaps in future, many people will choose to marry a robot rather than a human, as they are very realistic, intuitive, and intelligent, which you won't find. There is no wonder if they do that. First of all, one of the reasons or promises in marriage is that you would have a partner to help you in your old age steps. But unfortunately, both partners grow old simultaneously. Because both people age together, they become dependent, both of them become dependent on somebody else. But humanoids have a difference. They are the same at all ages. They will be at your service all the time if the batteries are there, and knows everything you need before you mention it. We have seen these robots doing remarkable jobs in hospitals during the COVID, treating the patients. So the future of humanoids must mostly be for the elderly people, period, and their needs. I personally look forward to a bright future when AI, the artificial intelligence, meet natural intelligence. I wish to leave you on this high note. Thank you. If you have any questions, I am happy to answer.
Sir,
Yes,
I'm Kartika and I have a question.
please.
Companies like Neuralink of Elon Musk tries to create AI built into human brains. Is this a way of approaching super intelligent AI better?
Hey, if I understood your question correctly, what you are asking is implanting AI things in our brain, right?
Yes, sir.
Yes. So this is an attempt that is going on to integrate biological integrate biological systems with the AI systems so that they'll behave very intelligently or behave as you want. There was an experiment which was done several years ago where something similar was implanted in the brains of cockroaches, which would allow a person to make the cockroach move in a particular direction, like a swarm of cockroaches move. So that was possible with simple AI tools that were implanted in the brain. But so far, we do not fully understand how.
So,
Yes.
uh, can I ask you something related to the reliability of an?
Can you please wait for?
We are not that much.
Can you please
Hello.
wait for a minute so that I will answer the first question and then come back to you?
Sorry, sir. I thought you finished the first.
Oh, no. Okay, so this is a problem. There is a problem here because we do not fully understand the biological system. We do not completely understand the biological system, and fiddling with something we do not know is a high risk thing. There is a lot of complications that can happen. So people speak about it, but rarely people advocate doing it in the real sense. We are not yet mature enough to, our understanding of biology is not mature enough to take us to that. Okay. Now, Tinu, please ask. Okay. Okay.
There was a presentation was excellent, sir. I came to know about many applications was in relation directly or they're not knowing their life. For example, but the for example, Elon in the car buying or financial revolution. So in that, so the people are trying to rely on AIs in our doing in our daily basis. Then AIs against all there should be some people who is just have the ability to manipulate all these AIs, whether it can be a threat in the future.
Okay. So I could not hear you properly, but I guess I understood your question. You're asking whether AI can become a threat in future, right? If that is the question you have asked, then yes. Okay. Uh, See, anything can be a threat. Even a knife can be used for good things and it can be used for bad things. You can kill a person with a knife and you can save a person with a knife, right? So it all depends on you, the person who handles it. And if AI, there has been a lot of care that has been taken, a lot of restrictions that have been put on the availability of technology for misuse uh, in the past. But these days, you are allowed to do whatever you wish. But it is it is considered as your responsibility to be caring, to be kind, and to be loving to the other person who is also entitled to live in this planet. You may have your own faith, you may have your own reasoning, but the other person also, in the same way, has a reasoning power, has a faith, or has a belief, or something different from you, and has the right, or has all the rights you too have to live on this planet. So whenever you are using technology, make sure that it is not doing any damage to another person, to the environment you are living in, or to the future generations. This is an ethical commitment each of us should have, and I believe that that is what education is supposed to do, and that is the only way we can hope that it won't be taken for doing damage to people. As I told about the cockroaches, somebody can control you with something implanted in you. This is a threat, but we believe that humans are much better than what we think as a negative possibility. That's our faith, and if we go wrong, life goes wrong. Life on this planet would be. facing the calamity. I hope I answered you.
Yes, sir. Can I ask you one more question, sir?
Please. Please ask.
Sir, we are now using, as per the presentation, we are now using AI as an extension of our own intellect. The things we can calculate with our intellect can be calculated by an AI in the medical field and in the agriculture field and financial field, in everywhere. Then when we are using it an extension, whether we have, for example, it lessens our opportunity for a cognitive development of each humans. For example, invention of mobiles or storage capacities could have reduced our memory power of remembering numbers and all. So whether AI, which is developed to have the power to be an extension of our intellect, whether it can be, for example, hindrance to our cognitive development of or intellectual development of a person in the future. For example, relying more on the AI, could it create a hindrance to our cognitive or rational or intellectual development?
This also will depend upon what you use the AI for. If I use the mobile phone just to see comics or just to listen to the news that are being broadcast daily, I don't make full use of the mobile. So it all depends upon what you use it for. Suppose a person who works in AI research, he is all the way worried about the ways in which he can enhance his knowledge, which has to be founded on very firm foundations, starting from the number system you study in standard 1 to whatever knowledge that is available today. So this building up will definitely make sure that you do not use it on use it on the surface. You won't be using it to drain off your brain power. See, if I do not know what number systems are or what multiplication tables are, maybe I see why I study multiplication tables in school. There are two purposes. One is to know what the product would be or what the numbers would be if I multiply one number with another. The other is to enhance the ability of your brain. If you have some other exercise which enhances the ability of your brain for a practical application, that would be well enough. You need not have to study what this multiplication table tells you. When you have a handy calculator, you can use your brain on something else. So it does not mean that you should be starting from the invention of the wheel to reach to the level that you want to reach. There are bigger problems which require more brain power at the higher level. But if you are using it at that level, then definitely you need not have to worry about any of these things. But if you are not using that, but if you are just using it as a media, then perhaps you may waste your energy, you may waste all the resources, and even whatever capability you have, you might lose, just following the Darwin's theory that unless you use something, you will lose it.
Thank you, sir. Thank you for that. It was very enlightening, sir.
Sir, I am Aishwarya.
Okay, please ask.
Can I ask you
Yeah,
ask you a question?
please ask.
Sir, we have artificial intelligence with the machine learning in various fields of daily life, such medicine, transportation, etc. Will it ever be a substitute to human?
Why you want to substitute humans? We created all these things for the welfare of human beings. And if we were to replace human beings, what we will do? I gave you one example where this, I mentioned geriatrics, for example, where all people would be taken care by these robots. That may happen. Or perhaps people may want to have friendship with some robots so that they'll have some kind of interaction with them all the time, which their human partners may not be able to enjoy. That may happen. But replacing humans with machines, that I do not think would be ever required or ever considered as an alternative. Unless we humans find out something that destroys us. We already have the machinery. One atom bomb is sufficient or one hydrogen bomb is sufficient to kill us all. Or if we have, nowadays we have biological weapons which very precisely kills a specified group of people. So those things are more dangerous than machines and AI.
Okay, thank you, sir.
So if you have any questions, please feel free to ask, or you can write to me. My email address is there. Then the web page of the ARS4 is there. We have several programs which are just introductory programs for students to get into this field. We try to be as heterogeneous as possible, trying to cover various fields, various topics, from marketing to medical science or to astronomy. We try to cover all of them, space science. So you're most welcome to contact us and to interact with us. Okay, I think there are no more questions. Shall I leave the dais for the organizers?
A message in the comment box or in the chat box. There's a question.
Oh, I see. Okay. How far are we from building a super intelligent as on its own? Should there be any concern of in being a reality? First of all, what you mean by super intelligence? Intelligence, see, whatever examples I showed you, like for example, the folding of proteins, it requires super intelligence to do it. If you mean by super intelligence what, like something that our brain cannot think of. Our brain so far is not able to understand why a particular protein folds in a particular way, or how a protein would fold if I give it a chain of amino acids. So it's super intelligence. We have already reached that point. There are examples, other examples also. See, the way Google is able to answer your questions. Simple example. It's super intelligence. And do you know how many answers it is giving every second? It's close to 1 million or even more. So it's super intelligence. So we have already reached the super intelligence. It's nothing to fear about unless, as I said, we use it for good things. So it's the morality or the moral values that we need to more focus on these days. We need not have to fear about intelligence. I hope I answered your question. So there is one more question. Sir, has any country any specific law in this regard to regulate it? Uh, that I am not aware of. Maybe I have to Google and see whether there is any country that has put any laws on restricting uh, how far some technology can go. I don't think there would be any. Everybody is trying to be at the cutting edge. So you see a lot of things coming up which are all in the positive direction, and technological advancement is, as I understand, is not considered as a hindrance to the people or the security of the country. But that is my opinion. Maybe you should Google for it and find out. All social media commerce companies use AI algorithm to make users spend more time using their application. Shouldn't this be of concern regarding privacy, addiction, etc.? Say, what is the intention of the company? The intention of the company is to sell their product. And to make a sale possible, if they want to hold you for some more time, that's also their intention. So their interest is to just close a sale with you buying their product. For that, they will put in more attractive offers and attractive things. And some people get addicted to it. It is for each of us to know what we want. And I never go to any of these sites just to browse the things they have on show. I'd go, if I need something, I'll go and search for that particular thing. And if I find something interesting, I would go to another site, go to multiple sites, because all these Amazon, Flipkart, everything is on my mobile. I can easily do that. I'll find out the reviews. I'll go through the reviews and find out which people have found most useful and most recommended, and then go for buying it. Maybe I'll buy a sample one, test whether it's working as I expect, and then decide whether that is the one I look for. So it gives you opportunities to do it in a wiser way. But if you are just browsing through the things and spending your time all the time on that, then that's up to you to decide whether that's what you want or not. Yes. Okay, Justin, tell me. Huh? Okay. Yeah. Please tell me this. Yeah. Hello?
Sir also said that. Okay.
Just I'm not able to hear you.
Sir?
I'm not able to
Sorry,
hear you properly. Please tell me. Yeah.
Am I audible now?
Yes, you are.
Okay, sir. The question I want to ask that today the activities that we do in our social medias are getting a third party application or anything else. So that if we think in like that, is that for just or commercial use or for something else? Because there will be lot of chances to be a scam for scam. So.
Yeah.
Sorry, sir, network issue.
Yeah, that's okay. I can understand. If I understood you correctly, what you are asking is, see, whenever we are going through all this social media and doing things like that, won't our security be at risk? Is that what you wanted to know?
Sir,
Or our privacy will be lost. Yeah, our privacy. What will happen to our privacy?
Privacy.
See, privacy is an old story. You don't have any privacy in these days. It's only your imagination that you are having privacy. What is private for you? Whatever you say is being recorded. And in fact, WhatsApp recently made it very clear that from 2016 onwards, they are recording every conversation that you have made, and they are prepared to sell it to somebody who is interested to buy it. So everybody is doing that. There is no privacy. your web browser knows your password to the bank. Your web browser knows your password to Google account or whatever. So there is no privacy. Privacy is just your belief now. In fact, everything is open, and that's a simple reason why those people who do all these things, thinking that they are very clever in managing all these privacy issues, are being caught very easily. Whatever be the scam that you see, you have evidences supporting what that particular event. So it could be a message that you privately send. It could be a message that you wrote down on Facebook or some other media. All these things are now public. There is no privacy. So privacy is, forget about it. There is no privacy. If you want to be very particular about your privacy, you have to leave all these things, throw out your mobile, throw out your computer, disconnect from the internet, and go to some remote place in the center of the forest. Even there, I am not sure whether your mobile phones will be. See, even if you switch off your mobile phone, if you are using an Android mobile phone, even if you switch off your mobile phone, the mobile phone is on and it is knowing your location and it is communicating with the tower nearest to you, saying that you are here. So there is no privacy. Otherwise, you will have to throw your mobile phone somewhere or remove the battery and walk. Then it is okay. But whenever you put the battery back in, it will tell the tower that you have moved from that place to this place. So again, it's not easy.
Sir,
Yes.
there was a question from Jibia Babu asking about artificial sun that China had made recently.
Okay. This question has been coming in many times in different forms. It has nothing to do with artificial intelligence. It is more about the technology of maintaining a reaction for a few seconds that is happening in the sun. So, of course, this has technological advancement which requires AI, but it is not directly related to AI. So, what is the question about? They have done that. So what? See, in the sun, everything is in the plasma stage, and in a magnetic field, you can retain plasma. So that is the main idea here. And if we can do it at a larger scale continuously for some time, you can have open reactors where you can use it for harnessing energy like electricity and other things. But it's just a technological, you can say, a milestone, just to demonstrate what is possible. Sir, is artificial gravity possible? Wow, what do you mean by artificial gravity? The feeling of gravity that you always have. Even when you take a turn on a bus, the feeling that that makes you move to the side is something like gravity. Gravity is just the attraction of the sun, attraction of the planet or a massive object towards its center. But when you are taking a turn also, something similar is happening. You feel a centripetal force or a centrifugal force, depending upon which direction you measure it. And that is very much similar to gravity. So whatever that changes your inertia, you can say that is gravity. Your state of rest or your state of continuous movement along a straight line, that is change can be considered as gravity, although that is not the formal definition for gravity. And if you are, for example, if you are in a satellite going around the Earth, then you feel microgravity, meaning that you won't feel gravity, you will be able to float in the air. So you can withdraw gravity and you can introduce gravity, but only locally. And that is a term Albert Einstein used, not me, not my definition. You can remove gravity locally. You can stand in a lift and cut off the lift from the top, the string that connects to the lift, and you can be a freely falling body with no feeling of gravity. So gravity, if you are moving up the up the lift, you feel a downward thrust on your legs if you're moving at a very high speed, which happens when you are moving on a rocket to space. In those situations, you feel gravity. So all these are artificial uh, gravity, examples for artificial gravity. But I'm not sure whether that's the question you have asked. Can we effectively use AI to study chaotic systems? See, chaos just means a higher order. Chaotic systems are very determining systems. See, we call them chaotic. See, there are two kinds of systems. One is a highly ordered system, higher dimensions of order is there. They are chaotic systems. But there are random systems, randomly varying systems. Random systems is not easily doable using AI. But chaotic systems, of course, we can understand many things about the chaotic system. Even without AI, we can do that. For example, Liopono exponent that you have is a measurement of the chaotic behavior of the system. And dimensions, fractional dimensions, everything can tell you a lot about the particular system. And depending upon what you want to learn, if you want to predict the next event, of course, in a chaotic system, you need to know the initial condition. And the precision with which you know the initial condition, you can, of course, predict the future.
Sir,
Yes.
Anjana have messaged, using AI, we study protein structure of virus. It has many benefits. Is there any disadvantage for the same?
Disadvantage for knowing the structure of the protein? I didn't get you completely, Amrita. Can you please explain
Sir,
it?
it was a question in the inbox.
Oh, okay.
I read it to you.
Okay. Oh, okay. So using AI, we study the protein structure of the virus. It has many benefits. Is there any disadvantage? I am not aware of any disadvantage in knowing the structure of protein. But of course, if you are referring to these vaccines that we create and the possibility that they may have any disadvantages or bad impacts on us, that is what all of us are trying to study. Because as I mentioned, every activity that is initiated in your body is with reference to foreign proteins is by your immune system. And there is a process in which this immune system is able to identify and also handle a particular invasion of a protein. And that is with a lock and key kind of connection with the particular protein. And it depends upon your immune system and your genetic coding that you have, your genes, how this particular key for opening the lock, for identifying the virus is created. And the only risk is that if this antibodies that your body create go and attack other organisms in your body, then there is a threat. But that has nothing to do with AI. That has to do with your immune system, your own genetic problems. For example, when you have a COVID vaccine, some people get very complicated effects like heart failures, blood clotting, things like that, which are all complications because of the antibodies they produce. It's not for everyone. It happens for a very few fraction of people who have a tendency to create something that goes and attack their own body parts, thinking that they are foreign proteins compared to what they have been introduced through the vaccine. So that is only disadvantage, but that's not a disadvantage of AI. Perhaps AI will be able to in future identify such possibilities and provide different solutions for them, which is something for future science to discover.
Any more questions?
I think all of them have asked the questions, and if they want to, if they have additional questions, they can always contact me by email. Maybe we can wind up.
So, thank you, sir, for sharing your knowledge to the academic community. I kindly request all the participants to fill a Google form for issuing the participant certificate. The link of the same will be provided at the end of the meet. So, now let us invite Mr. Vishnu Vijayan, HOD, PG Department of Physics, to convey the vote of thanks. Vishnu sir, please.
Thank you, Amrita. Hi, everyone over here. I'm Vishnu Vijayan, Department in charge of PG Physics of SAS SNDP on college. I'm not going to turn on the video because my internet connectivity is not that great. I hope you don't mind that. It is an honor for me to have the opportunity to deliver a word of thanks on this occasion in the presence of our respected principal, Professor Sabina Balachandran, our chief guest and the speaker of this webinar, Dr. Nainan Sajid Philip. On behalf of PG Department of Physics, extend a heartfelt thanks to all delegates of this webinar for their presence. I extend my sincere thanks to our honorable chief guest, Dr. Nainan Sajid Philip, for taking out time from his busy schedule to share his knowledge and experience with us. I'm sure that the webinar will be encouraging for our students to develop a new outlook about modern science and its advancement, and also to pursue further in the field of science. Next, I must thank our principal, Dr. Sabina Balachandran, for her support and guidance for organizing this webinar, and I extend my sincere gratitude to our teaching staffs of our department for organizing this webinar, which has attracted persons from various fields and places. Also, I must not forget to thank the organizing team, our dear students, for working hard from the last few days to make this webinar successful. Thank you everyone once again for making this webinar a great success. Have a good night.
Thank you all. Bye.
Thank you, Vishnu sir. On behalf of the organizing committee and the audience, I would like to thank the great speaker of the day, Dr. Nainan Sajid Philip, who who has done a remarkable job of enlightening the participants from all over the world. I express my heartfelt thanks to the Honorable Principal of SAS SNDP Yogam College, Professor Sabina Balachandran, and the executives, deans, head, and faculties of both teaching and non-teaching of physics department. We thank them for their support and guidance, for encouraging us at every point of time in organizing this great event. Last but not the least, it's our bound duty to thank and appreciate all the participants, students, research scholars who have taken their valuable time to attend this program. Thank you. Good night.